This is then the second lecture in linear algebra, and I've put below my main topics for today. I put right there a system of equations that's going to be our example to work with. But what are we going to do with it? We're going to solve it. And the method of solution will not be determinants. Determinants are something that will come later. The method we'll use is called elimination, and it's the way every software package solves equations. And so, and elimination, well, if it succeeds, it gets the answer. And normally it does succeed. If the matrix A that's coming into that system is a good matrix, and I think this one is, then elimination will work. We'll get the answer in an efficient way. But why don't we, as long as we're sort of seeing how elimination works, it's always good to ask, how could it fail? So at the same time, we'll see how elimination decides whether the matrix is a good one or has problems. Then, to complete the answer, there's a obvious step of back substitution. In fact, the idea of elimination is, you would have thought of it, right? I mean, Gauss thought of it before we did, but only because he was born earlier. It's his natural idea, and died earlier too. Okay, so, but then, and you've seen the idea. But now, the part that I want to show you is elimination expressed in matrix language, because the whole course, all the key ideas get expressed as matrix operations, not as words. And,
of course, get the crap out of me.
Of course, that we'll meet is how do we multiply matrices and why.
Okay.
Okay. So there's a system of
So
equations.
we've had a little fun here.
Three equations and three unknowns.
Cool.
And there's the matrix, the 3 by 3 matrix. So this is the system.
So we'll complicate it while we're talking about it here.
AX equal B.
So what he's putting up to the board is first the beginning of... Oh, sorry, I wanted to go back and make it more complicated here, but he's going through first building Minesweeper is what he's doing here. And he's giving you the basic limits of how it works, but you wouldn't necessarily know that. But as you learn that, you invert that, and that generally makes you go through different variances of it. But no matter what you do, it's always going to do that type of variable. Well, let's say I didn't know how to play the game, or I'm in some complicated state of it.
We accept the first equation, it's okay.
There we go. There we go. 4. Oh, I didn't see that one before. What's that generally mean? And it'll get more comprehensive and generally segue a few situations that might pop up inside of standards that might correlate other models.
Our purpose is to knock out.
Well, again, this could be what you're looking for. This is just the mathematics of how that does very clean schematics. This is a capacitor, essentially. It's the one I need, though, because watts, voltage, and joules, right? If that's all coming through the pipes, it'd probably be some hot.
I'd like to stick to that convention. I'll do a subtraction.
Oh, you get this one.
First of all, this is the key number, right, that I'm starting with, and that's called the pivot. I'll put a box around it.
Sometimes that's what you're looking for. Well, out of the two results I did, and they kind of have the same thing, I was a little bit more of this than I was that. Okay, great. Did you matrix that thing, though? I put it on a piece of paper for notes. I tried to note it. I noted them both. I'm looking at them now.
But I'm going to use it. And now finally let me ask you what the multiplier is. Yes. 3. 3 times that first equation will knock out that 3. Okay. So what will it leave? So the multiplier is 3. 3 times that will make that 0. That was our purpose. 3 2s away from the 8 will leave a 2. And 3 ones away from 1 will leave a -2. And this guy didn't change. Okay. Now the next step. So that step of this is forward elimination. That step's completed. Oh well.
Yeah, you don't
say,
need to.
Wait a minute. What about the right-hand side? Shall I carry the right-hand side? Is like gets carried along. Actually, MATLAB finishes up with the left side before, and then just goes back to do the right side. Maybe I'll be MATLAB and do that. Okay. So I just I'm leaving a room for a column.